Welcome back. I'm now gonna go over a couple of general probability rules. The first one is the general addition rule. So for any two events A and B, the probability of A union B or A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So the idea here is that if you look at the Venn diagram, so A and B might have an intersection. So the probability of A or B means is the probability that the probability that the outcome belongs to either A or B. Now the probability of A and the probability of B, if you think of them as proportions of outcomes in A and B, then P of A and P of B, they double count the outcomes in the intersection of A and B. So that's why we need to subtract the probability of A and B. Let's say we want to know what's the probability of randomly drawing either an ace or a heart from a deck of 52 cards. So if you have a deck of 52 cards, then you remember that there are there are four colors, and then we have these denominations, diamond, heart, spade, and clubs. And there are four aces in the deck, and there are 13 hearts in the deck. So there are four aces in the pack and 13 hearts. However, notice that one deck is both an ace and a heart. So the probability of getting an ace or a heart is equal to the probability of getting an ace plus the probability of getting a heart minus the probability of getting ace and heart. And the probability of getting an ace, well, there are four aces, so out of 52, so 4 over 52. The probability of getting a heart, there are 13 hearts, so the probability is 13 over 52, minus the probability of getting an ace and a heart. Well, there is only one ace of hearts, so it's 1 over 52. So at the end, this quantity reduces to 0.3. So the probability of getting an ace or a heart is 0.3. Let's say we roll a die twice and observe the sum of the numbers that face up. Then the sample space is given by all the numbers between 2 and 12. So again, we are rolling a die twice and we are observing the sum of the numbers that we obtain. A is the event of observing a sum that is a multiple of 3. So A is going to be 3, 6, 9, and 12. B is the event of observing a sum that is an odd number. Then B is 3, 5, 7, 9, 11. I want to know what is the probability of A or B. Now the probability of A, well, the number of, so this, the probability of A is the probability. How do I find the probability of A? Well, I just add up the probabilities of the outcomes in A. So the probability of 3, if you recall from our previous examples, the probability of 3 would be 2 over 36. Probability of 6 would be 5 over 36. Probability of 9 would be 4 over 36, and the probability of 12 would be 1 over 36. So again, when you roll a die twice, there is a total of 36 pairs of numbers we're going to get. And for example, 9, how many ways can I get a 9? Well, if I get the couple of ways I can get a 9 is that I get a 5 and a 4, or a 4 and a 5, or I get a 6 and a 3, or 3 and a 6. So there is a total of 4 ways I can get a 9. So that's why the probability of 9 is 4 over 36. Again, so probability of B again is the same way. We just take the sum of the probabilities of the outcomes in B. And so for example, the probability of getting a 7 is 6 over 36. Again, the reason for that is how many ways can I get 7? Well, I can get 7 by using 6 and 1, 1 and 6, so that's 2. I can get 5, 2, 2, 5, that's 4. I can get 4, 3, 3, 4, that's 6. And no other ways I can get 7. So the probability of getting a 7 is 6 out of 36. So at the end I get 18 over 36. So the probability, also the probability of A and B, well, probability of A and B. So what is in the intersection of A and B? Well, which elements are in both A and B? Well, 3 and 9. So we just take the probability of 3 and 9 and we add them. The probability of 3 is 2 over 36. The probability of 9 is 4 over 36. So we get 8 over 36 as the probability of A and B. So the probability of A or B would be probability of A plus the probability of B minus the probability of A and B. So which would be 12 over 36 plus 18 over 36 minus 8 over 36, which is 11 over 18. I must say that this is not the only way we can do this problem, but I'm doing it this way to show how we can apply the probability rule for A or B. Next, we look at the conditional probability. So the conditional probability of an event B, given that A, so the conditional probability of B given A is, so we write that as with this bar. So the probability of B given A is equal to the probability of A and B divided by the probability of A, provided that the probability of A is not 0. So basically, so this is so this probability is telling us what? Well, given the information that the event A has occurred, now we are asking what's the probability of B. So the fact that we know that A has occurred, right? Since A has occurred, now the possible outcomes are restricted to the outcomes in A. So that is, A now is the sample space. So again, the fact that we are given that A has occurred, it means that the possible outcomes are restricted to A. So A is the sample space. Now we are asking what's the probability that B is what's the probability of B. So then we basically should be looking at the outcomes of B that are also in A. So that's why you're getting the probability of B and A, the probability of A and B divided by the probability of A. So think of A now as the sample space. So if I roll a die twice and observe the sum of the numbers that face up, then the sample space is given by the numbers between 2 and 12. A is the event of observing a sum that is an odd multiple of 3. So A would be either 3 times 1 or 3 times 3, which is 9. And then B is the event of observing a sum that is an odd number. So then B is 3, 5, 7, 9, 11. So we can ask, what's the probability of B given that A has occurred? Well, the probability of B given that A has occurred is going to be 1. Well, if A has occurred, so notice that both of the elements of A are in B. So if A has occurred, then B certainly occurred. So the probability of B given A should be 1. But we can also apply the formula here. So we take the probability of A and B divided by the probability of A. So the probability of A and B is what? Well, if you took the intersection of A and B, you're going to get the same as A because A is inside of B. So the intersection of A and B is A. So then according to this formula, you'll be dividing the probability of A by the probability of A, which is 1. So from this rule here, we can write down a product rule, a multiplication rule here. That is, if we solve for the probability of A and B, we get probability of A times the probability of B given A. So the probability of A and B is equal to the probability of A times the probability of B given A. Let's say we want to know what's the probability of randomly drawing 2 hearts from a deck of 52 cards, and recall that there are 13 hearts in the pack. So let A and B be the events that the first and the second cards drawn are hearts. So again, what I'm saying, A is the event that the first card is a heart, and B is the event that the second card is a heart. So assume that the first card is not replaced before the second card is drawn. So the probability of A here would be, well, 13 out of 52, which is 1 over 4. And the probability of B given A, so given that A has occurred, notice that now I have 12 hearts in the deck, so now it'll be, and 51 cards left in the deck, so it'll be 12 over 51. So the probability of getting 2 hearts would be the probability of A times the probability of B given A, which is going to be 1 over 4 times 12 over 51, and we get 3 over 51 at the end. Notice that the probability of a heart on the second draw depends on which card was removed on the first draw. Independent events, so A and B are, if A and B are independent, then the probability of A and B is equal to probability of A times the probability of B. 2 events A and B that both have positive probability are independent if the probability of B given A is equal to the probability of B. So if the conditional probability of B given A is the same as the probability of B, then we say that A and B are independent. What is the probability of randomly drawing 2 hearts from a deck of 52 cards? If the first card is replaced, the cards are reshuffled before the second card is drawn. Well, in this case, the probability of A is 1 over 4, and the probability of B given A is still 1 over 4 because drawing was done with replacement. And the probability of A and B would be probability of A times the probability of B, because here A and B are the events A and B are. So again, here I'm assuming that A is the event that the first card is a heart, and B is the event that the second card is a heart. So in this case, A and B are independent, so I can just multiply their probabilities to get the probability that both A and B occurs. So in this case, we get 1 over 16. Consider 2 events A and B for which we have the following probabilities. Probability of A is 0.5, probability of B is 0.2, and the probability of A given B is 0.7. What's the probability of A and B? Well, so the probability of A and B, recall, is the same as probability of A given B multiplied by the probability of B. So if we multiply if we multiply probability of B with probability of A given B, we're going to get the probability of A intersect B. So which is going to be 0.2 times 0.7, which is 0.14. Next, ask what's the probability of A or B? Well, by the addition rule, we know that it's going to be the probability of A plus the probability of B minus the probability of A and B. Now, if we add these two numbers, we get 0.7, and the probability of A and B was 0.14, so we subtract that from 0.7. So 0.7 minus 0.14, which is going to be 0.56. What is the probability of B given A? Well, the probability of B given A is the probability of A intersect B, which is 0.14, divided by the probability of A. So basically we divide 0.14 by 0.5, and that's going to give us 0.25. So again, this probability of B given A is the probability of A intersect B divided by the probability of A, and the probability of the intersection of A and B we found to be 0.14, so we divide that by 0.5. Here's another example. Let's say we have a shipment of computers received by a retailer consisted of the following configurations of 80 or 120 gigabyte hard drives and 2 or 4 gigabytes of memory. So here we have a computer shipment, and it looks like we have a total of how many? Well, it is 25 here. Yeah, total of 100 computers here, and then we have 15 of them have 80 gigabyte hard drive and 2 gigabyte memory. 55 of them have 120 gigabyte hard drive and 2 gigabyte memory, and so on. So a single computer is selected at random from that shipment. B is the event that the computer has 120 gigabyte hard drive, and C is the event that the computer has 2 gigabytes of memory. What's the probability of B and C? Well, the probability of B and C, so basically the total number of computers is 100, and we count how many computers are in both B and C. Well, that means how many computers have 120 gigabyte of hard drive and 2 gigabytes of memory. Well, 55 of them. So 55 divided by 100, so that's 0.55. Same situation, we are asking now, what's the probability of C given B? That is given B. So that is given that we picked a computer with 120 gigabyte hard drive, what's the probability that the computer has 2 gigs of memory? So knowing that B has occurred, what's the probability of C? Well, so in this case our sample space reduces to B. So that is, we're looking at the computers that have 120 gigabytes of hard drive. So there is a total of 75 computers with 120 gigabyte of hard drive, and 55 of them have 2 gigs of memory. So then we divide 55 by 75, and that's going to be the conditional probability here. So we're going to get 0.73. Again, we are dividing 55 by 75, yes. Suppose that there are 3 balls in a box. On one of the balls is the number 1, on another one is they are numbered 1, 2, 3. You select 2 balls at random and without replacement from the box, and note the 2 numbers observed. The sample space here consists of 3 equally likely outcomes, 1, 2, 1, 3, and 2, 3. Disregarding the order, so let X be the sum of the 2 balls selected, and in this case the distribution of X would be the following. So the sum of the numbers that are selected could be either 3, 4, or 5, and each one is equally likely, that is given here. So each has probability 1/3. Okay, so I'm going to stop here, and we will do some more examples in the next video.